So guys, this is a capacitor. A capacitor stores energy in the form of an electric field. Now, let's connect it to our stabilized DC power supply and try to charge our capacitor. We have switched on our stabilized DC power supply. Now let's connect our capacitor to charge. Now it is charging. Now, as you can see from this circuit, this is our power supply and this is our capacitor. As I have told you, a capacitor stores energy in the form of an electric field. And this is what happens. When you connect your capacitor to power, according to conventional law of current flow, current will flow from the positive terminal of the battery, following this direction up to the capacitor. But when the current reaches here, this positive charge cannot cross because there is a barrier. So the positive charge will accumulate on this side. Positive charge will accumulate on this side of the capacitor. According to the law of electrostatics, this positive charge will attract a negative charge from the negative terminal of the battery, and negative charge will flow to this side and accumulate on the other side of the capacitor like this. The accumulation of the positive charge on this side and the electrons on the other side, according to Coulomb's law, will cause a force between these two plates. There will be a force, which according to Coulomb's law is called the electric force. According to Coulomb's law, the electric force F will be given by a constant K, the Q plus, which is the positive charge, times the Q minus, which is the negative side, over D squared, which is the distance between the two, the distance D separating these two plates. This force will consist an electric field or an electric potential gradient or potential difference, which is given by E is equals to V over D, where V is the voltage of the battery and D is this distance separating the two plates in the capacitor. This electric field, which is the potential gradient or potential difference, is what constitutes the energy stored in the capacitor. If we disconnect our capacitor from the power supply, if we remove our capacitor from the power supply, now it is charged. It is constituting a positive charge on the one side and a negative charge on the other side. Now, if we connect a load here in the form of a resistor, which could be a bulb, it could be a heating coil, if we connect a load across, these positive charges will constitute a current, will constitute a conventional current, which will flow through the resistor, do some work in the load, and then return to the negative terminal of the battery. And when it returns, this positive charge will accumulate on the negative side, causing a neutralizing effect to this negative charge on the negative side, and this causes the capacitor to be discharged. Now, that is how our capacitor works. We can remove our capacitor from the charging now. Because our capacitor is 16 volts, we have charged it with 16 volts from our stabilized DC power supply. Now, let's see, sorry, our capacitor. Now, we can remove this and use it to see if our capacitor has been charged. The capacitor has stored energy in the form of an electric field, which I can show you. You can see, we'll see some sparking. You can see capacitor has stored energy, and now we have discharged the capacitor again. So that is how a capacitor stores energy.